All right, and now for number 8, we have this thing that talks about password entropy. They tell us that password entropy is a measure of the predictability of a computer password. The higher the entropy, the more difficult it is to guess the password. And so the relationship between the password entropy P, measured in bits, okay, so this is important. We have one variable P, and the number of guesses G. So G is number of guesses G. While P, they tell us, is password entropy. Required to decode the password is given by blah. So this whole equation is what we have to work with. All right, I know it looks nasty, okay? But for now, you can think about it like one of these is X, the other one is Y. You have a log going around. The 0.301 is just a constant, it's just a number. Let's not be too scared right now, okay? There's no reason to be scared. Part 8. Calculate the value of P for a password that takes 5,000 guesses to code. Alright, we still don't need to get scared. It's fairly straightforward. Number 8, part A, as we can see, what we have is calculate the value of P for blah, 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 blah. Okay, so all I know is that I have this equation here. See, 0.301P equals log 10G. Alright, so it's very important, you guys, that we walk around with a good intuition about these exercises. Okay, so when they tell you to calculate the value of P, that means that P remains as what? It remains as a variable. So P is something that is not going to change. And then they tell me 5,000 guesses to decode. So guesses is which variable, P or G? Well, I know that P stays as a variable, so I'm not going to touch it. I know that G is number of guesses. That's why it's important to highlight buzzwords, as I put in yellow. And so now G is going to equal 5,000, given what they tell me here. And I need to find the value of P through that. Okay, so I'm going to put 5,000 over here, and we see what happens. Okay, now from here, I'm sure a lot of you, give me a second to open this up. It's probably going to be important in a second. Yeah. So from here, a lot of you are probably like, yo, what the hell, what do you do? See? Now, first things first, you guys. Um, you need to get P alone. See? There's only one variable here. You need to get the guy in red alone. Okay? Right now, the guy in red, how is it being affected? It has a 0.301 right next to it being multiplied. That means you need to, what's the opposite of multiplying? Dividing. So you multiply by 0.301. This goes away with this. And I end up with some number on the right side. So I end up with P equals log base 10 parentheses 5,000 divided by 0.301. Now, guys, I know a lot of you from here are like, dude, what the heck is log? When I try to put it into my calculator, like the little 10 doesn't appear. Like, what do I do? All right, guys, this is why it's important to know some certain stuff about intuition, the intuition of logs, and stuff like that. See? First things first, logs have two components. Okay, even in this exercise, you can see it. You have what they call the base. Okay, so this can be base 10, it can be base x, it can be base 2, it can be base 5, and a whole different thing is what goes inside the parentheses. Okay, so just bear in mind that this base, okay, can go changing and it affects how the log behaves. Now the default, okay, como lo que viene por de fábrica, como the default, all right, is always going to be 10 for log. Okay, so for log, the default is 10, and for natural log, the base is e. Okay, that's just your defaults. Okay, so when in your calculator, for example, you write log 5, it is assumed, because it is the default for log, that there's a hidden 10 here. Okay, it's not so different that when you find the square root of 4 and you equal it to 2, it's because by default there's a hidden 2 here. Okay, so you're asking the calculator what number multiplied by itself twice gives you 2. Okay, it's very different when you have something like this. It's which number multiplied by itself 3 times gives you 2. And the default is that this number here is hidden because it's assumed it's 2. If they change it, then it shows. Okay, in this case, it's a little bit tricky because they put the 10 even though the 10 is the default. So technically, over here for this exercise, I can just put a fraction using alpha f1. Okay, alpha f1, then the first option, it blah, blah, blah. I can do log 5,000 because the 10 is implied, and I divide it by 0.301, okay? And that would be quite literally for part A, see? Now, I know some of you might be thinking, okay, but what if the day of the test, instead of log 10, they put, log 11? Come on, fuck, like, now I can't do anything. All right, guys, the day of the test, you walk in with a couple of things, okay? With your calculator, with your formula booklet, with your brain, with a pen and pencil, hopefully don't forget it, and like 30 minutes of sleep, okay? And everything you've learned the past 2 years of this thing they call AB. See? Get very familiar with all the tools you're going to use that day because those are the tools you're going to have to play with, okay? And one of them is the graphing calculator. And the cool thing about the graphing calculator is that you can literally do fucking anything, okay? You can, dude, it's crazy, okay? You can do whole summations. You can do whole integrals if you don't like integrals. You can do whole derivatives as well, And lo and behold, if you go to math, see, now I have to find it, but I know it's around here. Here, log base, see? So if you press math, okay, and this is the thing, I didn't know exactly where it was, but I knew it was in here, okay, and that's the level you guys need to reach, okay? Maybe you don't know exactly where to find it, but you know where to search, right? You don't know where your hammer is, but you know which room it's in. Okay, that's what matters. Okay, so for this exercise, even if you don't know that 10 is the default base, you can put it in fraction, you can press math, you can scroll all the way down, you can press log base because it lets you put the base. So you put 10, put parentheses 5,000, and then below you put 0.301. Press enter, you get the same answer, but now you're a little bit more relaxed, okay? So whenever you need a plug-in base, if it's 10, if it's different than 10, it doesn't matter. You have the tools to do it, okay? That's the main message I wanted to show, see? So again, I know some of my videos, they extend a little bit longer than maybe they should, but I think it's important that you guys know these things. So whatever, man. You picked this video for a reason. Fuck you. Part A, 8A is going to be, as we see in this calculator, 12.2889. If you want to leave it in significant figures, what you do is that you count 1, 2, 3. The third one to the right, should you round it up or down? You do round it up because it is 5 or above, in this case 8. So the significant figures following the mark scheme, actually, it's going to be 12.3. 12.3 what? Don't forget your units, bits. All right, so that is part A. We talked a lot about logs, but it's going to be helpful down the road. For part 8B, okay, let me make a little bit of space. Kapow. Yeah. For part AB, we have write down G as a function of P. Now, a lot of people here are like, what is this saying? See? So when they tell you write down G as a function of P, it's basically like, get me an equation where I can express G in terms of P. You know when they talk about in terms of? Okay, this is the same. Maybe that's a little bit more friendly. I mean, this is the same as if they told you, write down G in terms of P. It's the same thing. It's literally the same thing. And so what you need to do is that you need to take this equation that we have in blue, okay? Well, that I just put an asterisk in red. So this equation, yeah? And you have to reach G equals something, 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 P, okay? So you need to have G alone. Okay, that's the key idea. You need to keep G alone. G is alone, and whatever else on the other side is going to be something, 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 P. Okay? We're about to find out how to do that. Okay? Now, for parts 8b, it's a little bit tricky because my equation is 0.301 P equals log base 10, and the number that's inside is G. So here it's a little bit harder because what a lot of people might want to do is just, oh, you can divide by log base 10. No, that's not really how it works. I'm sure there's a way to do it that way, but uh, I think there's a simpler way, okay? So right now you need to get G alone, and you're in a tough spot, right? G is like inside the log, so it's hard to work with that. What do you do? Well, Know your tools. Know your formula booklet. Find everything you can in your formula booklet about logs and see if it helps. Especially when you're stuck, this is a good thing to do. So you're stuck here. You don't know what the hell to do. You don't know what the fuck to do. G is in here. There's a log next to it. You never understood logs. It's the day of the test. God damn it, what do I do? Pull out your formula booklet. Look for everything you can find about logs. Where might logs be in these chapters? Number and algebra, something I never understood. Let's go to that page. Page 3 or 4, it's probably around there. Page 3 or 4. Lo and behold, exponents and logarithms. There it is. Okay, there it is. And so what this is telling you is that this is actually like a log property, which is, I don't know what's the name of it, but I like to think about it like the definition of log. Definition of log. See? The thing about log is that it's a cool way to connect exactly exponents with logarithms. See, so notice how you can go from a to the power of x equals b to x equals log base a times b. See, these are the same a's, the same x's, the same b's, the same a's, the same x's, the same b's. See, and there's a couple rules that go behind it, but it's pretty general stuff. Okay. Point is, you can turn this log into this other sort of equation thing. See? So let me just go ahead and write that on this side because it's gonna be damn useful. Let's put it in purple because why not? So we have that a to the power of x equals b is quite literally the same as x equals, yeah, log base a times b. See? I mean not whatever. See, parentheses b. So if I try to apply this, and I need to go like piece by piece, let's go piece by piece then. So in this context, what is A, what is B, and what is X? So in this context, following this here, okay? In this context, A would have to be 10. Why? Because we're talking about log 10, ¿cierto? I mean, the base 10, okay? So A is 10, that means this A over here is also 10, okay? Okay, what else? What else? What else? So B is what's inside the parentheses, which is just G. All right, cool, cool, cool. So we have this. That means we have this. I'm only missing X now, of course. What is X? X is what it equals to, what the log equals to. So X is it 0.301 or is it P? Newsflash, it's both. Damn. Yo, that's kind of cool though. So that means I got this, and I also got this. See, so if I go ahead and plug everything in so that I end up with what's on the left, okay? If I go ahead and plug it in, what I'm gonna end up with is, well, we said that A was 10. We said that X was 0.301p. And we said that B, the one that's alone, equals G. Ah, okay. So, damn, I'm just gonna rewrite it down here because I like it when it's on the left, because I'm like that. But look at that. I got G alone. And what were we trying to do? Get G alone. See? So I'm going to have G equals something something P. Well, in this case, P is on the exponent, but yo, I have something something P. I have G alone. That's all I need to do to write down G as a function of P. That is part B. Kapow! Look at that. All right. And now for part C, you need to find the number of guesses required to decode a password that has an entropy of 28 bits. Write your answer in the form blah, 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 blah. All right. So when they tell you this, this is what they call scientific notation, okay? And just so that we're a little bit friendly with this Z symbol is for integer, okay? What are integers, you guys? Integers are negative and positive whole numbers, okay? When I talk about whole numbers, an integer would be like -2, 1, 0, 1, 2, to infinity, okay? And also to negative infinity. See, let's not forget about, let's be inclusive, see? So, that is for integers, okay? So all it's really saying is that, yo, like rewrite your answer, just that you multiply it by 10, and this 10 is to the power of something, and that something has to be a whole number, okay? Oh, and A has to be between 1 and 10. So this is scientific notation. So if you guys want to Google it a little bit or search for my other videos that have it, scientific notation is your buzzwords to understand this better. I'm still going to explain it now because some of you probably have never seen it and you deserve to understand it well immediately. So, for part C, find the number of guesses. Okay, so when they say find the number of guesses, which variable is that? Okay, by now you should notice you're trying to find G. Okay, so G is now going to be your variable. And what you're going to be plugging in is that it has an entropy of 28. See? And so the entropy of 28, they talked about password entropy before. So in other words, you can associate entropy to P. So that means that P equals 28. ¿Cierto? Cierto. All right, team. So that means for part 8C, I can take the fancy, formula that I put on the right side and I can leave G as it is. And we're applying that P equals 28. See? That is a P. Why? Because that's what you said over here. Yeah. So G equals 0.301 times 28. All right, so you can go piece by piece here. See, for example, you can say, okay, 301 times 28. Okay, that's not like a whole number or whatever, so you end up with something a little bit weird. You end up with 10 to the power of 8.428. See? Now, is this what they're looking for? No, because as you can see, k has to be an integer. In this case, it's not. Okay, so some of you might try like combining the exponent. It's still not an integer, so there's still work to do. Okay. For scientific notation, what I suggest is get your answer like as raw as possible. Like get to the answer, okay, like the long string of numbers, and then convert it to scientific notation. And I'm about to show you how. So let's take that 10 and put it to the power of 8.428. So here's my nasty answer. See, my nasty answer is 26,791. 26,791,683, 2, comma 5. And so that means I have 1,000. Yeah. Wait, these are commas. Sorry. Kind of used to doing it in the other version. Yeah. So this is my number. It's a nasty number. It's super long, but you probably don't know what the fuck to do with it. See? So when you use scientific notation, it's basically like a nice way for this number to look prettier. Okay, and it's a way to sort of like define it better or whatever. See? Um, strictly speaking, what you want to do, so notice how they tell you that A is between 1 and 10. See? So basically, A can be whatever number it can be, but not above 10. So for example, if you want to start, okay, your scientific notation from here, and then writing everything else, you would be starting from 26. Okay, that's not legal. But what you can do is start it from here. Okay, so if you start it from here, what you would be doing, if I do a scientific notation, I would be putting 2.67916832. Okay, so that means basically I took this number from before, I took the first digit to keep it between 1 and 10, and I put everything else as a decimal, right? And I multiply it by 10 to the power of 8. Why does it work that way? Why do we multiply to the power of 8? Because, ladies and gentlemen, the cool thing about scientific notation is that it helps you move the thing I put in a very dark color, this guy, see? And so that is my decimal place, okay? So this is 0.5, dale? Como 1.5, okay, that's the point I'm talking about, 0.5. And so the scientific notation, what it does is that it moves that decimal around, okay? Right now, my decimal is all the way over here, ¿cierto? It's like technically it's here, see? Technically it's here, and the way to move it back, okay? For example, take this long number, see? Just the decimal form or whatever, just so you guys understand the idea. So if I take 2.679, 16832, okay, and I multiply it by 10, what's gonna happen to the decimal? Ah, it moves one over. What if I multiply by 10 again? Ah, it moves one over again. Okay, so what if I multiply by 10 squared? How many times is it gonna move? Kapow! It moves twice. Yo, so that's what it's doing. So how did you reach 8? Well, I literally counted. 1, 2, 3, 4, 5, 6, 7, 8. And ladies and gentlemen, kabow! You now understand scientific notation. So that is the answer for part C. If you want to get fancy, what you can do, which is, it's in the mark scheme, it also works, okay? You can say, okay, well, I need to put 2 point something, right? But I don't want to put the long string of numbers because it doesn't look nice. What you could do technically is say, well, this same number here, but you're going to be counting 3 decimal places for significant figures, right? 3 significant figures. This one, do you round it up or down? You round it up. So technically, this you could leave it as 2.68 times 10 to the power of 8, okay? They're both in the mark scheme. They both work. That's it. Okay, whatever. That Anyways, that was a long explanation, but I'm sure someone out there needed it. So whoever it was, good luck, brother. You got this. Or sister. Yeah. Then they tell us that there is a point on the graph of the function g of p with coordinates 0, 1. Okay. Explain what these coordinate values mean in the context of computer passwords. I'm going to say one thing right away. Guys, if you reach this exercise and you have no fucking idea how to do part A, if you have no fucking idea how to do part B, if you have no fucking idea how to do part C, you can still do part D, okay? I know that usually you need to solve these exercises like, oh, part B needs part A and part C needs part B. So, like, if you get stuck at the beginning, you're stuck forever. Okay, that's sort of true. Okay, sort of true. Generally true, okay? But sometimes some of these exercises, okay, you don't need the parts from before. You can answer part D without anything else, okay? And I just want you guys to notice that, because the day of the test, if you're fighting for points, if you have time but there's an exercise that you're stuck on part A and you can't solve it, you tried all your tools, it's not coming out, look at part B, look at part C. Not only can it be a hint for what you need to do for part A, but also maybe it's an exercise you can solve without needing the stuff that's before it. And that's a free point right there, dude. So, there's a point on the graph of the function g of p with coordinate 0, 1. What does this mean in the context of computer passwords? So, we have 0, 1, right? And we have the function g of p, see? So 0, 1 means that you're plugging in 0 for p and getting that, technically, ¿cierto? This means that g equals 1, see? So, this is telling me, so let's remember that P is password entropy. So when entropy equals 0, then the password, okay? Sorry. When the entropy equals 0, then the guesses you need are 1. And if the guesses you need are 1, technically you know the answer, okay? So if you're a computer hacker, I guess this would be the case. I guess, I'm not sure. If your password is like 123. Okay, if your password is 123, the entropy is pretty much 0. It wouldn't take a lot of guesses. The computer would figure it out right away. Okay, so the answer for this part, for part D, we're going to be saying that I would just express the point 0, 1 means that with an entropy of 0, the amount of guesses needed are just 1. All right, so that is what I would express. I'm sure that would get my score. If you want to know how the answer key has it, it's not anything from another planet. If a password has an entropy of 0, then the password can be guessed in 1 try, or the password is known. See? Again, notice how in this tab they tell you references must be made to both entropy and number of guesses. that's really like just use the buzzwords. Okay, when you use the buzzwords, you're gonna be using entropy for P, guesses for G. Okay, but yeah, that is about it. That is for number